So here's some physical motivation of antiderivatives, and by physical I mean from physics. Okay, so from physics, is that the wrong way to say it? Physical motivation? Or something else, right? Okay. Maybe motivation from physics. Is that better? Motivation from physics. All right. So let's go back to this question about ball being thrown upwards. Okay, so you throw a ball upwards, and usually, in physics, to make things interesting, they throw a ball on the top of a building on a cliff. Because on a level ground, it's less interesting. So you have something like 20 feet tall cliff or something, and then you throw a ball. So let's say that the initial position of the ball is about 20 feet. Okay? And let's say the initial velocity, you throw the ball up by, say, 40 feet per second. So in this question, so let me see, example one. Okay. Find the velocity of the ball and the position of the ball at time t. This is in seconds, okay? All right, what's not included in the question, but which is assumed that you know, is that while this ball is in motion, we ignore any kind of air resistance or wind acting on this ball, but we do include one kind of force, which is the gravity force. And gravity acting on any kind of objects, they give you something called gravity acceleration, right? So what is this thing called gravity acceleration? G is negative 32 feet per square second, approximately. It changes from place to place, but this is like approximate value. If you're very high up on the mountain or in some other places like near the equator, then this value will change a little bit. But let's assume that G is equal to negative 32 feet per square second, which seems to be the usual value that we take when we do physics. Okay? So from this, we can say acceleration A is what? The only kind of acceleration that the ball is experiencing is the gravity acceleration, right? This is G, which is negative 32. Now, what is the relationship between the velocity and the acceleration?
Velocity, the acceleration is like the derivative of
Right.
velocity.
Acceleration is the rate of change of the velocity, right? It measures how fast the velocity changes, right? So we can say that whatever this vt is, I don't know the formula for it, but if I differentiate it, I'm going to get negative 32, which is the acceleration. And since we just found an awesome, very cryptic looking symbol, we'll kind of write it this way. So you're doing the antiderivative of negative 32. That's what we're trying to find. That's the way we're going to do this. But what is this really? What differentiates the negative 32? Okay, so let's just think about this. T squared differentiates to 2t if you differentiate, and t differentiates to 1. So if you think about negative 32 as negative 32 times 1, and think that 1 is the one that got differentiated, and negative 32 was just some constant multiple, right? Then if you integrate the 1 that's attached to it, we're doing the opposite of this, right? So you'll be getting negative 32t, and then you have to put a plus c because of the integration constant, okay? And whenever you do this, in the beginning, you should always try to check whether it makes sense or not. If you differentiate this by t, what would you get? Negative 32t differentiates to t becomes 1, and you do get negative 32, right? What about this plus c? What do you get if you differentiate it? Constants differentiate to 0, right? So you do get negative 32 as your derivative, and therefore this here is the correct answer. We know that negative 32t plus c is the correct answer. So that is your v of t. However, we haven't fully figured out what v of t is yet because it has this unknown c. How do we determine this? Okay? The process of finding out what the c is called the initial value problem because usually these plus c's are determined by what it was when it began. Okay, so initial value problem. And look, what is v of 0? According to this formula, what is v of 0? Okay, v of 0 is 40, then I agree. But according to this formula, what is it? Negative 32 times 0 plus c, right? So what is that?
C plus 4.
That's c. And from there, just using the fact that v0 means the velocity at time t, meaning that you have to plug in 0 for t here, you see that c has to equals to 40. Which means that your vt is negative 32t plus 40. Now we can go for the position. Since the position is the altitude, the height, let's use y for the position, okay? So yt is now the antiderivative of the velocity because, again, it's the same reasoning. If you differentiate, the rate of change of the position is equal to velocity, therefore the antiderivative of the velocity must be the position, right? So you have to take what you acquired here, negative 32t plus 40, and integrate by t to get something. Okay. Now this requires a little bit more thinking than before because if you differentiate t squared, you get 2t, not t, right? So what do you have to differentiate in order to get t? See, we see a t here. I want to find the antiderivative of t. So let's think about this. What do you differentiate to get t? T squared differentiates to 2t. So if you want just t over 2, right? T squared over 2 differentiates to t, right? Therefore, when you're integrating this t, negative 32 is just a constant multiple. So just like when we're doing derivatives, we just put it there without paying much attention to it. What we really care for is what is the antiderivative of t? That is 1/2 t squared. Because when you differentiate this, 2 comes forward, canceling this 1/2, right? And then 40, you should think of this as 40 times 1, and you're integrating 1. So what is that? 40 times t. And is this the answer?
Plus C.
Plus c. Okay. Now, when I grade exams, any missing plus c is worth 1 point. Okay? So it's a policy that I always had, and some students in my Calc 2 class get punished a lot for that because a few students will forget it for the entire exam, and the entire exam is almost like 10 questions of these, so you get like automatic 10 points deduction. So that's pretty sad. And, yeah, so don't be that person. Okay? So don't forget this plus. But again, are we done?
No.
We're not done. Why?
Some of the concepts were.
Because we still need to know that plus c. Okay. I just erased it, but I have y of 0, the initial position as 20 feet. The ball was 20 feet above the ground when it was first shot up. And therefore, that means y of 0 is 20. And therefore, when you have y of 0 evaluated using this formula, this is your y of t obtained by the antiderivative. If you plug in 0, 0, then you just get 0 and 0, and then plus c. C is the only thing that you get, and since these two are equal, you get c equals to 20. And then plugging this back into this formula for y of t, now finally you have the answer. Y of t equals to 32 and 1 half cancels to negative 16. Negative 16 t squared plus 40t plus c. Okay. So that's the answer. So sorry. Plus c was 20, right? Plus 20. So now we have the answer for the position. This is the answer for the position. No, C was 40 here. Okay, so
It's different. It's different in the next.
it's a different C.
Okay.
So maybe if it's confusing, you might want to put C1 for this one, and put a C2 for this one, if that's.
Got it. Okay.
That's often done when you have many C's appearing at the same time. Okay. All right, so this one is the answer for the position. Let me write down position. And this one is the answer for the velocity.